Hello children, today we are going to discuss an important topic, the number system. As you are aware that the number system is very important chapter for us to understand the concept of the mathematics, as it plays a vital role in various disciplines of be it the science, be it the mathematics, and in every field you can see we talk about the numbers. And what are the various types of the numbers that we are going to take up today in our topic, that is number system. To understand the concept of the number system, we must know the various types of the numbers that we have been doing from the lower classes. Let us brush up our knowledge and recall those concepts of the various types of the numbers first, and which will help us to understand the concept of the number system more clearly. And here our topic is the number system. Now let us try to understand the concept of various types of numbers in detail. So first of all, here today we are going to take our topic, that is number system. In number system, we start with the counting numbers. As you know, counting numbers are those numbers which start from 1, 2, 3 and going endlessly in one direction. So what type of the numbers we are discussing here? And you may be knowing these types of the numbers, we call them as natural numbers. And what are the various numbers that we discuss here? As you have been doing it, that the natural numbers, they start from 1, 2, 3 and so on. All the counting numbers are known as natural numbers. So here the question arises now, which is the smallest natural number? As it is evident, you can see the numbers, the natural numbers, they start from 1. So the smallest natural number here is 1. And what about the largest natural number? You can see as the natural numbers, they don't have any limit, they don't have any end. So we cannot find any of the largest natural number. So what can you say about that? The largest natural number is not defined. So these are the natural numbers. Now, if we take again the natural numbers, 1, 2, 3, so on, and if we add 0 to the class of natural numbers, what type of numbers are these now? Do we call them natural numbers? No. These types of the numbers we call as whole numbers. So these are the whole numbers now. Whole numbers. If we come to the definition of the whole numbers, if we would like to explain the whole numbers in the simpler terms, we can say these are the natural numbers along with 0. So in case of the whole numbers, as they start from 0, 1, 2, 3 and they go endlessly in one direction. And here you can see that they don't have any limit, they don't have any end. So they are also boundless numbers, limitless numbers. So in this case also, the largest whole number we are not able to find. So if we are not able to find, so what we can say about the largest whole number? That is not defined. Now the question arises here that if we want to compare the natural and the whole numbers, what is the difference between the natural and whole numbers now? You can see the natural numbers, they start from 1 and the whole numbers start from 0. Now, I would like to ask you a question here, that can we say all the natural numbers are whole numbers? So to get the answer of this question, we must see every member of these natural numbers, be it 1, 2, 3 and so on. So many numbers can be there. We have to check that whether these numbers are present in whole numbers as well or not. As it is evident, you can see 1, it is present in whole numbers. 2, is it also? 3, and likewise, we may see so many of the numbers in the set of naturals are also present in whole numbers. So, it is quite evident now here that we can give natural numbers the name as whole numbers as well. Now the same question, if we want to check whether all the whole numbers are naturals. It is evident that the whole numbers, they start from 0. If we want to check whether 0 is present in set of natural numbers, it is evident, you can see 0 is clearly absent here. 0 is not present here. So all the whole numbers are not natural numbers. So there is an exception. We can say all the whole numbers are naturals except 0. So this is the concept of natural and the whole numbers. Now, if we would like to extend this concept of the numbers further, let us take these whole numbers again. You can see 0, 1, 2, 3, and so on. If we add with these whole numbers the negative naturals, natural numbers with the negative sign, and what we call such type of the numbers, if we have whole numbers that are the positive numbers along with the negative naturals, what sort of the numbers we call these? As you may be knowing, these types of the numbers we call as integers. Integers. So if we would like to define the integers in the simple words, we can say that the integers are the whole numbers along with the negative naturals. If we would like to ask ourselves the same question, that which is the largest positive integer, you can see on right side, as we are aware about the fact that on the number line on right side we have the positive numbers and on left side we have the negative numbers, and integers comprise of such type of the numbers. So if we look on the positive part of the integers, you can see they don't have any end. So they are limitless on the positive side. And what about on the negative side? If we look on the negative part of it, so they are also the limitless on the left side as well. But here we denote the positive part of positive side of the numbers which are not defined. We can say which are limitless, which are boundless. All those words we can use here. So we write it as positive infinity. And for the negative numbers on the left side, we use sometimes the negative infinity. So they will go endlessly on the right direction in the positive direction, and they will go endlessly in the negative direction. So same case and the same question we may ask here about the natural and the integers. Can we say all the natural numbers are integers? You can see all the natural numbers are present in the class of, or sometimes we use the word set of integers. So all the numbers are present here in integers as well. So we may give them the name the integers as well. For the natural numbers, we may use the term integers as well. Likewise, for the whole numbers, you can see all the whole numbers, they are present in integers. So we can use the word the integers for whole numbers as well. Now, if we reverse the concept of naming the numbers, what can we say about the integers? Can we give them the name? Can we give to integers, to all the integers in fact, the name of natural? You can see, can we write them as natural numbers? All of the integers are natural. Here we have to check. Here there is involvement of 0 first, that is not present in naturals. Involvement of the negative numbers, you can see in case of the naturals, no negative number is present there. So we cannot give them the name as natural numbers. All the natural numbers are integers, but all the integers are not naturals. Same is the case when we use the comparison between the whole numbers and the integers. You can say all the whole numbers are integers as they are present there, but all the integers are not whole numbers, as there are negative numbers present in integers, while as whole numbers are fully the positive numbers. Now, there are some other types of the numbers that may be striking our mind when we use the term number system. That is, different types of the numbers are there. Sometimes we have been using the terms like the even numbers. Even numbers, when we talk about the even ones, these are the numbers which are completely divisible by 2. So, what you may be thinking in your mind about the even numbers, so the type of numbers which are of this form, 2, 4, 6 and so on. Similarly, the numbers which are not completely divisible by 2, what sort of the numbers we call them? We call them as odd numbers. So, what are the numbers that can be taken the examples of the odd numbers here? So, we use here 1, 3, 5, 7 and so on. Similarly, there are some other types of the numbers like composite numbers. Composite numbers, as you have been doing it from the lower classes, that composite numbers are those numbers which have more than 2 factors. The possible examples can be here, starting with the which has more than 2 factors, can be 4, 6, 8 and so on. So, composite numbers are those numbers which have more than 2 factors. The possible examples we took here 4, 6, 8. If we see the prime factors of these numbers, you can see 4 is divisible by 2, it is divisible by 1 and the number 4 itself. So, in nutshell we can say these are the numbers which have more than 2 factors. Those numbers which have more than 2 factors are known as composite numbers. And on the other hand, the numbers which have only 2 factors, which don't have the factors more than 2, what sort of numbers are those called? As you know, those numbers are known as prime numbers. So, what are the possible examples that we can take for the prime numbers? As they are divisible, that they are having only 2 factors, that is the number and the 1 itself. So, the first one we can take 2, then 3, then 5, so on. So, these are the possible examples. In fact, you must remember here in case of the prime numbers, from the set of evens 2, 4, 6, you can see there is only involvement of one number from the evens, that is even numbers, that is 2. This 2, in fact, you will remember, this 2 is the only even prime number in case of the prime numbers. So, sometimes the question is posed in the examination regarding when you are asked about the MCQs, when you are sometimes asked in the MCQs that which is the only even prime number. So, you must think that the only even prime number, when you are using the word prime, which means having the 2 factors only. So, among the even numbers, you can see 2 is the only number which has only 2 factors, the number 2 and 1. And these sort of numbers, they will satisfy the property, they have only 2 prime factors, the number and 1. These are the prime numbers. So, this is just an idea of the basic terms of the number system that we are taking here. In fact, we have to discuss in the great detail. That is, we discussed natural, we discussed the whole, integers, even, odd, composite and primes. Now, we have to take the important set of the numbers that are actually the fractional numbers. You may be thinking in your mind, what sort of the numbers we are talking about? It is the numbers which are in the form P by Q. The numbers in the P by Q, for which the denominator, that is Q, is not equal to 0. And where we say that these P and Q, the numerator and the denominator, they belong. This is the notation, mathematical notation that we use for belongs to the integers. So the numbers of this type are known as the rational numbers. Rational numbers. As you know from the definition of the rational numbers, the numbers which are in the form p by q, where denominator cannot be equal to 0, it is not equal to 0, and p comma q, they belong to the set of integers. I would like to ask you here one question, that the fractional numbers that we discuss, they are also in the form p by q, like that. Sometimes we write a by b, where we say the condition is b cannot be equal to 0, as you are aware about that. And in this case, if we try to differentiate between the rationals and the fractions, in fact, these are the fractions. Fractions also, they have the numerator, they have the denominator, where denominator is not equal to 0. Here also denominator is not equal to 0, but the only difference here is that these a and b, they cannot be negative, but they belong to only the whole numbers. In fact, the condition here is, in case of the fractions, this b cannot be equal to 0. But a and b, they can belong to the set of whole numbers. They are only positive numbers. So this is the only difference between rational and the fractions. They are having the same fractional notation, but the difference is this numerator and the denominator here belongs to the integers, while in case of the fractions, you can see the numerator and the denominator, they cannot be negative. Now the question arises here, if we want to do the comparison between the natural and the rational numbers now the question will be here, that can these natural numbers be put in the form p by q? That means, can we give them the presentation of p by q notation? So for that, see, can we put here in the denominator as 1? No. Yes, we can put 1 in the denominator. It doesn't change the natural number. So 2 by 1, 3 by 1, and so on. That means, if we have presented the natural numbers in the form p by q, that means we can give them the name as rational numbers as well. Same is the case with whole numbers. Can we put them in the form p by q? So there is no harm in writing 0 as 0 by 1. It doesn't change its identity as the 0. It is again same, that is 0. 1 divided by 1, 2 by 1, and 3 by 1. They can be put in the form p by q. And if we generalize this result to the set of integers as well, you can see they can also be put in the form p by q. In fact, be it natural, be it whole, and be it integers, we can put them in the form p by q. Now, if we would like to reverse the concept of comparison between these sort of numbers and the rational numbers, can we say all the rational numbers? Rational numbers, if we took different examples here, if we took different examples of the rational numbers here, see, they can be 2 by 3, 4 by 5, minus 9 by 17, etc. These are the numbers in the form p by q. They are in the p by q and they are pure rational numbers. So, can we say 2 by 3, if we compare it with the natural numbers, 2 by 1, if it is 2 by 1, we don't have any objection in saying that 2 is a natural number. But instead of 1, the denominator involves here 3. So we cannot say this is a natural number. So all the naturals are rational numbers, but all the rational numbers are not natural numbers. Likewise, we can do the comparison between the whole numbers and the rational numbers. They are in the form p by q, so whole numbers, we can give them the name rationals as well. But all the rational numbers, we cannot say all the whole numbers. They can be the whole numbers if they have the denominator as 1 and they don't involve the negative sign. In fact, the whole numbers are totally the positive numbers. Similarly, all the integers we can give the name as rational, but all the rationals we cannot give them the name as integers. Now let us extend the concept of studying the rational numbers. What are the numbers? We must know that what are the numbers? They are in the form p by q, but whether they are in the standard form. So the question is here, what is the standard form of the rational numbers? For any of the rational number to be in the standard form. Now let us try to understand what the standard form of rational number means. So we will be taking now the standard form. Standard form of rationals. So far we know that what are the rational numbers. They are in the form p by q, and q is not equal to 0. P and q, the numerator and the denominator, they belong to set of the integers. The important point is that we must remember while writing any of the rational number to be in the standard form is number one, that is they must be in the proper fractional notation, proper fractional form. Proper fractional form. As you have studied the chapter fractions, there we discussed the various types of the fractions, as proper fractional form of the numbers is also one among them. Now, when numbers are said to be in the proper fractional form, when they have the numerator is smaller than the denominator. The possible examples can be, we can write, that is like 2 by 5, 6 by 7, 9 by 11, etc. So in all these examples you can see the numerator is smaller than the denominator. So this is the first point we must remember while writing any of the rational number to be in the standard form. Number two is that the numerator and the denominator must be co-prime to each other. What we mean by the co-prime numbers. So, first of all, we must have knowledge of the co-prime numbers. Co-prime numbers are those numbers which have 1 as the highest common factor in between them, which is, in simpler words, we can say that they must be in the lowest terms. Lowest terms means, if we take the examples, here, first of all, the second point, what we have to note down here is the highest common factor, that is HCF, between the two numbers must be equal to 1. Here, HCF between the numbers must be equal to 1, which means, in other words, we can say they must be co-prime to each other. Co-prime to each other. Let us take few of the examples. I am giving you one of the example. 2 by 4, 6 by 9, C, 7 by 11, 9 by 13. You can see here from these, if you look at the several examples that we have quoted here, that 2 by 4, are these in, this is the rational number in the form p by q, there is no doubt in that, but are these in the lowest terms? Or in simpler words, can we go further for the cancellation of the terms? You can see, yes, it is 2 1s and 2 2s. So the resultant number here is 1 by 2. So to write any of the rational number as in the form 2 by 4, we cannot say that is having the highest common factor, that is in between 2 and 4, the numerator and the denominator, highest common factor is not 1. So what to do further? We have to go for the cancellation further for these terms to make these fully co-prime. That is, the highest common factor between these two must be equal to 1. Now, we have reduced this fraction 2 by 4 in terms of 1 by 2. That is actually the equivalent fraction of 2 by 4. So, here 1 and 2, you can see we cannot go further for the cancelling the terms. So, cancellation of the terms, highest common factor between these two is 1. So we can say 1 and 2 are co-prime to each other. Likewise, same is the case with 6 and 9. You can see, you can go for the cancellation further. That is 3 2s and 3 3s. That means we can give it the simpler notation as 2 by 3. So 2 by 3 is the number. You can see we cannot go further for the cancelling the terms. So the highest common factor here in between numerator and the denominator is 1. So this is what we mean by the co-prime. The numerator and the denominator must be co-prime to each other. They must be in lowest terms. And what about 7 by 11? You can see 7 and the 11, they have highest common factor as 1. Same is the case with 9 and 13. We cannot go for the further cancellation. So 9 and 13 are the co-prime to each other. Now the third point that we discuss to write any of the rational number in the standard form is, the third point we must remember is, the negative sign must always be with the numerator. Negative sign. Negative sign must be put with numerator always. Sometimes you may see the numbers, that is, I'm quoting you a few of the examples here. 1 divided by -2. Similarly, 6 divided by -7. These are the few of the examples we can quote and get our concept clear about what we mean by the sign convention, writing the signs in the denominator and the numerator. See, here you can see the negative sign is with the denominator. In fact, it is also a negative rational number. 1 by 2 is negative. But when we talk about writing it in the standard form, for that, what we have to do, we can bring the sign in the numerator as well. How to do that? We go for the rationalization. So we can multiply in the numerator and the denominator by -1. So that we will be able to convert this negative sign which is in the denominator to the numerator. That is, it will be -1 and divided by 2 multiplied by -2 multiplied by -1. It will be equal to 2. So this is what we mean by writing the sign in the numerator. So this is the third point, third and the important point as well, we can say, to write any of the rational number in the standard form. That's all for today. What we discussed from the beginning of the number system, different types of the numbers, then correlated the concept of the various types of the numbers, what can be the name given to them. And this is the, we can say, the brush up of the knowledge. Recall those previous concepts that will help us to understand the concept of number system more clearly. That is all for today. Hope you have understood today's topic well and would like to see you in the next session. Till then, bye-bye.